Also, when you go through this, it might be a good thing to keep this in front of you, because as you walk through this, this is what's going to help you go through each one of your rational functions. You know your x and your y intercepts, right? We know these. These are our zeros of our solution. We've been doing your zeros for a while. We have vertical asymptotes, and we find these after we factor and after we reduce. Because sometimes factors can cancel out. When they cancel out, they become a point of discontinuity, and we're gonna see those. We use our horizontal asymptotes. We have a couple of rules here, and you're gonna see these rules pop up again. You're gonna see these rules pop up again, and you're kind of gonna have to memorize this. It's not so bad because you can actually spot them in your graph if you forget them. There's just 3 of them. If the degree in the numerator is less than the degree in the denominator, in other words, when we have something like this, if the degree in the numerator is less than the degree in the denominator, that's what they're asking. If the degree in the numerator is equal to the degree in the denominator, if the degree in the numerator is greater than the degree in the denominator, that's where we're going to judge these from. So all we're looking at is the highest degree in the numerator, the highest degree in the denominator. We always look at the highest degree. It's kind of a really nice way to find your asymptotes. Domain and range, we've done those before. Your max and your mins, your increasing, decreasing. Sometimes we get these. Because we have a lot of asymptotes here, we get these guys. These guys have no max or mins. Even though they have a turning point, they kind of turn over here. It's not like a vertex point. It's just kind of an increasing, decreasing function. So they have no max or mins, but we do consider concavity in this. Even though it doesn't make the actual cave up, if you kind of turn it, it has a cave down look, it has a cave up look. So we consider this a cave up.
That's a cave up.
That's a cave up. This is a cave down. We're going to work a little bit more with those. That's the one that's harder to try to get a grasp on, because normally we're looking for the cave up, cave down. While it has no max or min, this would be completely a decreasing function, but it has a cave up. So these are the things we're going to address. And we get to point of discontinuity. That's a little tiny point that, even though we're not allowed to use that point, if we fill it in, if we approach that point, we can kind of close that point off. And we look for points of discontinuity, and we look for slant asymptotes. And a slant asymptote, when you have a horizontal asymptote or a vertical asymptote, you can see your graph go like this, right? When you see a slant asymptote, you'll actually have an asymptote, and it will slant up like this. So all your asymptotes are designed to guide your end behavior, even a slant asymptote. It kind of shows you where your end behavior is going to be. It's not as easy as, oh, this is even, they're both up, or they're both down. If it's odd, we did down on the left, up on the right. These work differently because they're rationals. They're not continuous. They're functions, but they're not continuous. So they work a little bit differently. So that I don't confuse you thoroughly, let's take a look at one.
Oh, you accidentally.
I don't know what happened. Let's investigate. All right, so let's walk through your list. The first thing we're going to do is your y-intercept. Well, first thing, do you have any domain problems here? Let's take a look at the domain. What causes a domain restriction here?
Variable in the denominator.
Good. The variable in the denominator. So we set this equal to 0. So our domain says x cannot be 0. So we're going to jump over the 0. Okay. Always good to take a look at your domain. The range we look at last. We got to look at your range last. So we take a look at your y-intercept. This one's easy because we just set x equal to 0. So x is 0, so this comes out to be y equals 1, 0. What do we get? Nothing?
There can't be a 0 in the denominator.
There can't be, right?
No.
So there can't be. So do we have a y-intercept?
No.
None.
You're confusing me for a second.
No, I was trying to ask you to work with me here. I tend to do that. I say, throw things at you and you got to tell me what you see. Okay, so we have no y-intercept. All right, and does it make sense? Did we see it cross the y-axis when you graph? No? Do we have an x-intercept according to your graph?
Yeah.
Okay, so let's work your x-intercept. Your x-intercept says it's the zeros of your numerator. So what's your numerator?
4x plus 1.
So set it equal to 0. And does that make sense? Does it look like it could possibly pass through that point? So that's good. So we've got your x-intercept, we have your y-intercept. Well, no y-intercept. Okay, so next step. We're going to factor and reduce. Can we factor this?
Why did you put 2 negative?
Because I wrote it down.
Oh, okay.
Sorry about that. I can't talk and write at the same time. So when we go back to this, just ignore my lines through it. It's still 4x plus 1. I just crossed it out when we were doing the zeros. Guys, come on. Stay with me here. Can we reduce that? Can we factor this? So no factoring. So now let's follow your steps. Vertical asymptotes. These are where this is important. After we do your asymptotes, we'll sketch. And you're going to see it work a lot nicer. Vertical asymptote says, after your factoring and reduce, your zeros up, find your zeros in your denominator. Now, your graph can have 1, 2, more than 1, more than 2 vertical asymptotes. Okay? And a graph can never cross a vertical asymptote because your vertical asymptotes come from your denominators. And if your denominator is set to 0, it cannot go through that number. So because we weren't able to find a y-intercept, x is equal to 0 here, wasn't it? And doesn't that make sense? We couldn't find your y-intercept. Where is x equal to 0? The y-axis. So we could not find your y-intercept because there's an asymptote right there. You're not allowed to use the 0. Generally, when you do your domain restriction, that's almost the same as your vertical asymptotes.
So your vertical asymptote is just the domain restriction?
It's just your domain, well, it's all your domain restrictions. But let me backtrack a little bit. They may not all be vertical asymptotes. They may be a point of discontinuity, but not today.
Okay.
Today we're just hitting like the asymptotes. Tomorrow I'll throw in the point of discontinuity. All right, one thing at a time. Horizontal asymptotes.
Wait, so you just put the line for your vertical asymptote?
Yeah, but right now we're not going to sketch yet. We're going to get all our asymptotes and then we're going to sketch.
Yeah, that's what I mean. You just...
Yep. Okay.
That's all I wanted to know.
Horizontal asymptotes. Follow the rules. What's the highest degree in the numerator? 1. What's the highest degree in the denominator? 1. So read your chart. If the degree in the numerator is equal to the degree in the denominator, then you have a horizontal line, and we say A over B. A over B means this: the coefficient of the numerator over the coefficient of the denominator. So the coefficient of the numerator, you might want to write this down, coefficient of the denominator. So y is equal to 4 over 1, or y is equal to 4. These are the asymptotes that's going to guide your end behavior. So now we can sketch this. Draw your asymptotes. You have x equals 0. This is one of your asymptotes. You have y equals 4. This is another asymptote. So now you put your asymptotes down because watch. Now watch how nice this is to sketch. It goes like this, and it goes like this. Isn't that what your graph looks like? Right? Doesn't the asymptotes guide to where their ends go? So your asymptotes are there for your end behaviors. They kind of guide where your end behaviors go. One thing to note, like we said before, you can never, never, never cross a vertical asymptote because that comes from your denominator restriction. But your graph can or may cross a horizontal asymptote. And we'll see that happen. It may cross over a horizontal, but it can never, never cross a vertical because that comes from your denominator. Okay? All right, so we know the domain. Now, we have to figure out your range. Your range says, it's all my y values. So my range says, if I come from negative infinity, I'm coming up like this, where do I have to stop? I can't go past this, right? I'm not allowed to use this. So negative infinity to 4. Do I have any other restrictions for my y?
No.
Nope. 4 to infinity. Okay? It's a little bit different than your other ones because your other ones were continuous. They made a little bit more sense. We found a max, we found a min. There was our range. We'll also have to use max and mins on this also sometimes, but this one has no max, no min.
Those, okay.
Because this is max up here, this is min down here, it has no max, no relative either. There's actually no turning point to this. It's not like a parabola type thing where you can find its turning point. We don't look for its turning points. Okay, now we can do increasing, decreasing. Increasing, decreasing. I follow from the left. I look to see what my y value is doing as my x increases. What's my y value doing? Decreasing. So from negative infinity to where? The x value that it stops at is what? 0. Where do I start again? What's the upper thing doing? Is this increasing or decreasing when I read left to right? From where? 0 to infinity.
So would you just leave?
It's decreasing. Your y is decreasing. Your y is decreasing here. Your y is decreasing here. We just kind of had to jump over your 0.
So you don't put increasing?
We have no increasing.
You just leave it blank?
Yeah, you just leave it. You wouldn't even put it in. I just put it down in case because we were looking for them.
Could you just put like the names?
You just, yeah,
Just so that way I would know.
yeah,
That like, okay, if I do that.
no increasing. Now concavities. We're looking for a concave up and we're looking for a concave down. Technically, this part over here, this is considered a concave up. So it's the same part of this decreasing die, from 0 to infinity. Oh, sorry, that goes over here. From 0 to infinity. This guy is considered a concave down, from negative infinity to 0. It kind of has the two little sections of your increasing, decreasing, whatever it is you're doing. You'll kind of see them repeat. Look at your domain. It all ties in together because what you have are a bunch of little graphs, like if you consider that a little graph. Little segments because you have asymptotes blocking them off. So at the end, your domain should also tie into this a little. You should see the exact thing. And wasn't 0 the guy that we were missing? We could see it in our domain. We can see it in our decreasing. We could see it in our concavity.
Yep.
Right? Okay, so these are the things I just want you to look at.
What is this for?
You have a line.
Look, it's cotangent.
Well, it's another piece of your function. You're going to see it. You're going to see it in a minute. All right. So, let's do your domain first. Domain. Do we have any domain restrictions here? Any problems with the denominator or radicals or anything else? So what do you say? X cannot be what? or
Y minus
positive or negative 1. So let's take it out of our domain. Negative infinity to negative 1, and jump over that. Or what? Negative 1 to 1. Don't forget that middle section. And 1 to infinity. Okay, don't forget that middle section. Alright, so we've got a couple of domain restrictions. And those domain restrictions are going to be where your asymptotes are. And can you kind of spot where your asymptotes are from your graph? Doesn't it look like the negative 1 and the positive 1 are not working? Can you go to your table and see where negative 1 says error, positive 1 says error? It says you can't use those, right? So it kind of all ties in together. Alright, y-intercept. We look like on our graph we have a y-intercept, so we set x equal to 0. So this is going to become 0, that's going to become 0. So what is y going to become? 0. Because this is a 0 in the numerator. When you get a 0 in the numerator and a negative 1 in your denominator, you're 0. Doesn't it go through the point 0, 0? Right? It goes crosses that x-axis? Okay. So now, can this, excuse me, can this be factored? Factored and reduced at all?
The denominator.
Well, yeah, we can do our denominator, that's all.
Yeah, it's not
Yeah.
gonna help anything.
But we can't, but that's okay. We want to factor everything because that helps us out. So now, let's take a look at your vertical asymptote. This is what's going to help you sketch your graph, your vertical and your horizontals. That's what gives you those guidelines for your sketch. So the vertical asymptote says the zero's in the denominator after you factored and you reduced. Now we have nothing to reduce today because when we reduce it, that's a point of discontinuity. I'm saving that tomorrow. So take a look at your denominators, your factors of your denominator. Same thing as your restrictions for your domain. X is negative 1 and x is equal to 1. These are your asymptotes. The same exact thing from your domain. We have nothing to reduce. Now we look for your horizontal asymptote. Your horizontal asymptote says, look at your highest degree in your numerator, look at your highest degree in your denominator. Find the first one. When your degree in the numerator is less than a degree in the denominator, you automatically have a horizontal asymptote of y equals 0. That's the rule. This is where your x-axis is. And you can kind of tell by your graph, you're kind of bouncing off that x-axis, but the middle one is going through it. They're allowed to go through a horizontal, but not the other kind. So let's sketch. Let's sketch. We sketch once we have all our asymptotes. So you have an x equals negative 1. You have an x equals 1. You have a y equals 0. This makes life a lot easier to sketch. So somewhere up in this part, I have something that guides along those axes, those asymptotes. Somewhere down here, I'm guiding along my asymptotes. And this guy in the middle happens to cross through this. So once you get all your asymptotes down, it's so much easier to sketch. What? I'm sorry? Well, they're guiding your end behaviors for your different pieces of your graph, if you will, for the different parts. They kind of guide your end behaviors. Your vertical asymptotes will never cross because your vertical asymptotes are from your denominator.
Do you use the domain restriction for the vertical asymptote?
Today, yes, but not tomorrow. Because tomorrow we're going to factor this out and have a different little problem in there.
Okay.
So today, yes. Today they met. I didn't want to throw everything at once because this is like a very different concept. All right, so x-intercepts. Let's hit your. We did your y-intercept. Let's do your x-intercept. These are the zeros of your numerator. So we take 3x and we set it equal to 0. And we can see the only time it crosses is after 0, 0. Okay. Again, we have no mins and no maxes. Okay. There's no mins, there's no max here. You will eventually see a graph that goes like this. Sometimes we have a slant asymptote that goes through here. We're not doing that today though. This will give us a min. But these guys, no mins. Because they come down and they keep on decreasing. A good way to tell is look at your table. Watch your x value go from 1 to keep on going. You can see your y gets smaller, 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 smaller. It never goes back up again. So you can't have a min or a max. You know what I'm saying? So just keep an eye on your y values. If you thought you had one. Down here, when we do this, yeah, you'll see your y value go back up. You'll be able to find your min, but not here or here. And this guy has no max or min either. So let's look at increasing, decreasing. So if I start at negative infinity, I'm following my y as it's decreasing. From where to where? Good, to -1, and it has to stop. It hit a wall there. Then I jump over this wall. What's my y value doing in this middle section? Decreasing. From where to where? Okay, I hit a wall. Now what's my y value doing in this last section? Decreasing. So again, I have no increasing. Okay. And your concavities, your concave up and your concave down. Which one's concave down, the left or the right side? Left. So let's do your concave down. Negative infinity to where? -1. And your concave up? 1 to infinity. So isn't it kind of all making sense here?
Wait, I didn't do domain right.
God bless you.
Thank you.